Hello, and welcome everyone to the IBM Tech Exchange Dev Day. We are having the presentation today on concert resilience and observability integrated product experience. So I'm introducing Eka Maurer, product manager for IBM Concert.
Hello, everybody. We are going to talk about resilience. Concert is IBM's tool that is focusing on resilience for executives, operators, but mainly for developers to make their life easier with a lot of the non-functional requirements and other elements that tend to go into that, oh my God, I have to do that again mode. So we want to dive a bit into how Concert can help with that, but mainly we want to talk about what is resilience and then how we are creating an ecosystem inside of IBM to really deal with resilience. There is a focused session at 3 p.m. Eastern on Concert's resilience posture by itself. If you're interested in what we do to help developers with Concert in that regard, please tune in later today as well. But when we look at something that's called resilience, it's a very interesting domain. First of all, almost everybody has an issue with resilience. And when we talk about it, like what is resilience? I always use and overuse the term, it's the art of coming up and staying up. Resilience is the translation of what the business wants to do towards what technology does deliver. And as we all know, when business and technology collide, you usually have what we're allowed to call lost in translation. What does the business want? And what does it mean for you as developers to actually satisfy those needs? I mean, that's what we measure in KPIs and other elements. But there is active work that needs to be done. And 80% of all organizations say that they don't have proper or sufficient application resilience. Next slide. One of the main things is you have too much information to actually understand your resilience. There's over 1,000 applications. And per organization, the larger organization have even significantly more, but even small organizations use hundreds of tools. Some are very simple tools like, well, not simple, but VS Code, IDEs, VI, Emacs, whatever people use. They are operating systems. You have your runtime environments, may it be OpenShift, containerized Docker systems, or bare metal, specialized hardware. All of those systems and tools actually have active components that monitor, manage, and help people to understand what's going on. I mean, about 30 years ago, what we tried to do with our software, developing software, deploying software, reached a point where the raw data we had just became too much. So we created what is today known as observability and automation. Tools that manage, assess, and understand things like performance of applications or networks. Things that allow you to do log file management. Tools that allow for interconnecting data sets. But all of that has created a tool sprawl, which we now face that to do a simple task, we have to look at 10 different tools at least. Doing that also means that we have to become an expert in those tools. And let's be real, nobody can be an expert in all the 1,000 tools that happen in the organization. So we have a problem of complexity. And our managers, our leaders actually see that because the complexity in IT directly impacts our ability to succeed. Actually, according to some research, 82% of all enterprise leaders say that the IT complexity is a direct impact on the company's success. It impedes it. And when things are impeded, when you have problems, when you not necessarily have the ability to see what's happening, it becomes a very interesting part because it costs real money. $300,000 per hour is the estimated cost of an outage. When I say cost, it's not what we pay necessarily. It includes things like lost opportunities. I mean, when Amazon is down, all the shipments stop, and they are transacting over $1 billion a day. So 300,000 is not necessarily high value when you look at the scale of some companies and how expensive it is. Actually, when the global financial system stops for a second, the estimated value per second of outage of the interconnect is measured in $2.5 million per second. And as you know, IBM is involved in about 80% of all financial transactions. So resilience of those, the ability to stay up and come up if something happens, is more important than it ever was. And developers play a key role in it. Hands on keyboard is actually what makes everything run. And if we don't have a good translation of what the business actually needs, what the impacts of those changes are, compared to what we need to do on a day-to-day basis, we actually will constantly get into the blaming game where people say, you did not do your job, therefore we have an outage. Might not be real. Boston Consulting did a study, analyzed outages. 54% of all outages are human error. But of those 54%, 77% was the best possible decision with the data available. Why? Because the data might be available, but it might not be complete. There is a lot of other things happening. And across 1,000 applications that you touch, well, it's very hard to actually have a sane view of everything that's going on. Next slide, please, Mike. So what we are trying to achieve now is, can we make a TLDR of all the information that you need to make good decisions? And can we give you the tooling, can we give you the information that you need to move from I need to have more uptime to I need to implement unit tests in that particular function because time has shown that this is the main cause of outages. We didn't have time to refactor, and I can't convince my bosses that I need to refactor that piece. But at least, can I have something that helps me of creating a continuous stopgap solution by constantly modifying and adjusting the unit test that I need to do and add more QA elements to the function that we can show why this needs to be refactored. Giving you a repeatable and scalable framework to understand where your resilience is failing, where you have gaps, but also giving you the automated tools. And when I say automated, I'm talking about AI augmented tooling. And don't freak out, AI is not the enemy. I always call AI marketing with math. Both together, that's AI. If you put a marketing person on mathematics, well, that's what you get. But the idea is there are tools that help you to do things at scale. I will talk more about it in my own session later, but if you look at a company like T-Mobile International, who is having 40,000 servers that need patching, doing that in a one-by-one manner is almost impossible. AI augmented automation has allowed them to significantly reduce the day-to-day impact it has on developers. And instead of having to work on patch management as a job, developers get to do what they're good at, what they love doing. They get to build new things. And that is possible because we provide a scalable framework to understand what needs to be done, boost it using AI technologies to get a unified data view and insights. We know before we take an action what could and can happen. And then we use AI to automate those efforts. Instead of applying 50 patches because there are 900 different system types out there, and each of them requires their own thing, instead of creating individual solutions, using the technologies that we are generating at IBM allows you to actually create one path, one workflow, which then automatically adjusts to the environment it's running against, allowing you to spend your time on the things that matter and allow you to scale. But none of this is possible in a vacuum. We need to get information from your tools, from your environments. We need to understand observability metrics. We need to understand cost impacts. We need to understand code. We need to look at GitHub. We need to look at your QA systems. Integrating and providing that information is a key problem because integrations are hard. And Mike, my friend Mike here, who manages the integration experience across the entirety of our portfolio, will walk you through a bit of what do we think, how to make integration simple, repeatable, but most importantly, painless. Mike, over to you.
All right, thank you, Ekam. Um, Let me just jump. So yes, and as you were mentioning, I am the product manager of integrated experience, and looking at the bringing our products together and reducing the friction. As Ekam was mentioning, we know a lot of you struggle with the various different tools that you've got, and also bringing in your environments and your existing technology environments. So this screen here starts to look at the different technology investments that you're probably dealing with already, right? You've got your on-prem workspaces, your cloud workspaces in the hybrid environments. Uh, you may be dealing with operations like Kubernetes, infrastructure as code, um, and network, right? So depends on where you are as a developer and whether you are just developing code or where you're carrying the pager, right? For applications that are written that depend on these stacks, you may have to jump between many different tools. So we do have four products in our resilience and observability suite from IBM. The first is what Ekin was talking about as far as resilience, and that was powered by IBM Concert. There's also a risk element of that as well that can look at your risk posture, look at your vulnerabilities, and be able to manage that in a very similar way to how Ekin was describing for resilience. The second is our monitoring and observability product. So this is IBM Instana, and this is where a lot of our customers will, manage, of course, their applications, look at synthetic monitoring, handle alerts, and for developers, do a lot of continuous development through that. So they'll often use the APM tools on their dev test environments as well as their production environments. Then we've got Turbonomic, and this is really a really neat tool that balances the cost you have versus your performance. And one of the things that we see a lot of developers do is, spin up everything you need to get your development done. And sometimes that moves into production, and we always want to make sure our latencies are low, so we over provision, right? No one's going to get dinged for having over provisioned server that performs well until it scales up. And then the bills start to come in, and looking at, should we be reducing those servers? Doing that by hand is a very painful process, especially when you're going across different clouds and different technologies. And Turbonomic handles that for you automatically. And then one of our newer acquisitions is KubeCost. And definitely in the Kubernetes world, being able to look at real cost that you've got in Kubernetes is key. And then these, of course, lead to the business outcomes for cost and planning, as well as health and performance. So one of the things that we've done is we've put these boxes together, and we've generated an integrated product experience. So at least for the users of our products, we're showing how these customers can work within these products with a single sign-on, with a common navigation, some common objects that we're sharing. So next, what I'll do is I'll actually go into a demonstration and show some of this in action in these four products and how we're bringing these to market. So I'll call this the operationalized resilience demonstration here. Okay, so the first thing that we're doing is we're looking at Concert, which is the product that Ekam was just showing. And the first thing that we see here is that we've got a resilience reduction in score detected. So we've got, a drop in our HR virtual assistants, right? And this is what we call our reduction in application availability. So let's go into actually review that change and see what is behind that. So now we get a set of recommendations, and these are coming in from the AI the Gen AI that Ekin was mentioning. So it's taking the data that has been provided to Concert, and it's finding us a couple of different recommendations. And the first one here is that we've got a previous version that we can roll back. And the second one is we're going to investigate a latency SLO. So we're going to follow the second one here and jump into what this latency SLO violation is. So it takes us directly into Concert. And from here, we see that we do have a indicator that's showing over the last time period, we have moved into the pink, and our SLO target of 95% is now at risk as we're down to 84%. And we're in a warning state, right? So we can see a lot of those responses that are coming in have started to trend into the poor state, and we're also eating to our air budget. So this is something we definitely want to click into. The next view of Instana. What's happened next is it's triggered us an actual event. So when you look into the event, it starts to now show a little bit of a zoomed out view of how that metric violation or how that metric's been trending. And when we go over to the right here, we can start to see for the last 2 days, we've actually crossed this threshold into the warning state before. And it's showing a daily seasonality pattern that our HR bot tends to struggle during the parts of the day when it's getting peak utilization. And in the evening, it's tending to recover. So it's not something that's a continuous issue, but it is something we definitely want to look into a bit more. So we'll scroll down on the page. And now what we're seeing is a probable root cause, which is a new capability in Instana, and it's actually powered by agentic AI. And this is a great technology that's helping developers and operators as well, because when you look at the different tools that you've got, of course, anyone that's using a tool a lot becomes an expert in it, becomes very quick to find where are things like probable root cause from a lot of different things that an APM tool would look at, like metrics and logs and traces. And what the agentic AI is doing that for you as it's a trained expert. So it's going through those logs and traces, and what would maybe take hours for a new person to the tool, it's coming back very quickly and saying, given all the evidence that we're seeing, what is the probable root cause? So in this case, our HR bot is saying that we've got evidence that we've got our aggregated calls are experiencing latency and errors, and they're traced to some of the services deployed on an under-provisioned node pool. So we'll scroll down and we get a bit more of the explainability of that. So what did the AI actually look at? So it'll give us the associated event summary. Here are the things that it went through, and then also giving us the indication that it found from an error log. So those are the things that the AI is using to prompt us with the diagnosis. And is saying that the Ask HR application is experiencing this elevated latency due to resource exhaustion in its underlying Kubernetes cluster. So the cluster is under provision for the workload demands during peak usage. So it's noticing that there's that seasonality, and that's causing the process to throttle and leads to delays in the processing. So it's a very nice description that the agentic AI has come back, and it's giving a very high probability that this is the root cause. Well, it doesn't stop there, because it goes down and gives us a set of recommendations and recommended actions to take. So this is really going to help us now with what do we do with that. And the first recommendation here says to resize the GPU node pool in the cluster that's running our HR bot. So if we want to click a bit more and see, what is that specific recommendation, this takes us into Turbonomic. So we've now switched context, right? Or I should say we've kept our context, but we've switched actual products. So we've gone from Instana into Turbonomic. And within Turbonomic, this gives us a detailed view of what it was analyzing on that balance between the cost that we've got and the performance. You also see that it's estimating what will be the impact of the resources after it takes these actions to increase the GPU capability that we've got here from 1 to 2 GPUs on the nodes that are assigned to our node pool. It will estimate those and also give us an estimate of cost. So we can see if we take this action, we're going to get an increase of cost here. And that will help us with that provisioning of that resource that we need. And with the power of Turbonomic, we can also run that as a continuous evaluation. So we'll go ahead and do that, apply an automated policy. And now we go back to Instana and we can see that our Ask HR app is now running in a better state. The calls have quieted down, and you can see where the action is that we've done this. We've also see a pop-up that shows that we've got another product available for us called IBM KubeCost. And as we mentioned, like we increased those resources, but then we also started a policy to start to evaluate those over time. And since it was a Kubernetes resource, this is very relevant that I want to set up Kubernetes and see how those recent changes are actually shaping up. So give me the real view of how those Kubernetes costs are increasing and look at that from within the tool. All right, so here we see back to an Instana view. Over here on the left, this is where we first had our incident, and this is where we increased our resources to solve the problem. And the HR bot cost of the cluster has gone up. And then we've got the secondary action that we took where we've asked Turbonomic to run a policy and continually look back and make sure that we aren't over allocating during all of the time. And that's actually reduced the resources in the evening when we're not using the HR bot as heavily. So it's giving that view of the increased GPU resources has increased the cost temporarily, but then when the policy kicks in, it's actually dropped the costs. So this is exactly how we were hoping things would look. And then we can also broaden down to an overall view of what KubeCost is giving us by namespace. So it'll show us a table of our actual runtime that we've got our LLM in that's running our chatbot. We can see our GPU, CPU, network costs, persistent volumes, load balancer, and the trends over time. So we can see for that overall HR bot runtime that we're running, we now have an overall trend that is down about 12%. And then, of course, KubeCost can also show us the different runtimes that are running and get that overall view of the cost for Kubernetes. So then bringing it back, we do have a overall view of going back to our application that we've got and looking at what was all done. So as we go to a summary view from Concert, we can see that our resilience score has actually increased for our Ask HR app. And as we look at our performance and monitoring that we've got from Instana, our HR bot is now up. We're meeting our SLO. We have dropped our number of critical incidents. And when I look at the Turbonomic, we actually have started to accumulate savings over time. So that's giving us a nice view across our different applications of how that data has all come together. And with the actions that we've taken, the HR bot is now very good. So the approach that we're looking at here really starts to bring in the agentic AI and being able to help the developer run these tools and connecting the different tools together. So we saw Concert, Instana, Turbonomic, and KubeCost come together and really help to move at the speed of the application. So as issues come up, allows you to discover them and fix those issues very quickly before they're impacting your end users, and to assure that the applications are highly available and continue to perform. And with the actions that we're able to automate in Turbonomic and run the policies, you can do these also without the cost overruns. So this is really what we mean in practice when we talk about scaling resilience and bringing your different products together. So the IBM advantage really when using the stack here, the full stack for observability and resilience is, not just about the uptime, right? Because it's also about, as developers that are carrying the pagers and, you don't want to be woken up in the middle of the night on the weekends to handle these things. You want your tools to help you get ahead of those. And really that's increasing that resilience. So you just don't have those issues and you're able to use the AI to your benefit to help you find these problems, help you get the parts that are resilient, and is really the foundation for running reliable and digital services at scale. So IBM's got the most robust portfolio to manage that resilience and really everything you need to do to monitor your system and your applications, control costs, and manage FinOps as well. So that's our presentation. I will pause here to see if anyone has any questions for either Eckham or myself on either the integrations that I've been showing or the resilience part that Eckham was talking through.
Seems like no questions.
Okay, we'll wait a minute to see if any other questions come in.
Okay. So thank you all for attending and listening. As I said, there will be a separate session on Concert with much more of a deep dive on how AI and automation of resilience helps developers, not just the business side, but actually how can we make your life easier at 3 Eastern um, on the same link, I would assume, as part of the Dev Day. And apart from that, thank you all for attending. And if there are any other questions, please feel free to reach out to us, to Mike or myself, via all the various channels, and our emails will also be shared as part of this. Then, thank you, everybody. Mike, final words?
No, thanks for showing us the new capabilities we've got in resilience, and love to see how this whole portfolio is coming together. So thank you, Eckham.
Thank you, Mike.
Okay, we'll see you.
Thank